Let's look at the definition of the quotient of powers property. So when we find the quotient, so I see my division of two algebraic expressions with the same base, you can subtract the exponent of the divisor from the exponent of the dividend and use it with a common base. So the rule for this property would look like this. So let's say I have a base of A and it's raised to, let's say, M. So any number that we could put there. So I have two, these have the same base, so my base is A. My first A is raised to an M, and my other A can be raised to anything. So let's just make it N. This would be equal to the base, so my common base here is A, and I can subtract my two exponents. So I would have M minus N. So this time, instead of using an integer for a base, I'm going to use the letter Y. So I'm going to have my variable of Y raised to, let's say, the 7th. And I'm going to divide it by Y raised to the 4th. So the first thing I see is that I have common bases of Y. And I see my division sign. So I see that I can use my quotient of powers property. So just like before, I can take this and I can have Y raised to 7 minus 4, so I can subtract my exponents. And 7 minus 4 gives me 3, so I have Y to the 3rd. Let's test this out with our canceling strategy. So if I have Y to the 7, I have Y times itself 7 times 4, 5, 6, 7, divided by Y to the 4th. So I have Y times itself 4 times, 3, 4. And now I'm going to cancel them out, so I can cancel that group, that group, that group, and that group. So that leaves me with Y times itself 3 times. So I'm left with Y times Y times Y, which can also be written as Y to the 3rd. And these two solutions match. Let's try another one. Let's try a negative P raised to the 5th divided by a negative P raised to the 2nd. So using my quotient of powers property, I have the same bases of a negative P. So I have a base of a negative P. And then I can take my exponents and subtract them. So I have 5 minus 2. So this would equal negative P raised to the 3rd. And if we go back and write it out with our cancellation, negative P times negative P times negative P times negative P times negative P 5 times. And then I have negative P times itself 2 times in the denominator. I match them up, and I see that I have 3 factors of negative P. So I'm left with negative P times negative P times negative P, which is the same as negative P times itself 3 times. So again, my solutions match, therefore showing that I can subtract my exponents and I get the correct solution. The quotient of powers property can be used to simplify expressions. So let's say I was given the expression h raised to the 6th power times k raised to the 2nd divided by h to the 5th times k. Alright, so let's start out by writing this as a fraction to make it easier to look at. So I'll have h to the 6th times k to the 2nd divided by h to the 5th times k. So now I can break these apart, so I can look at just my h's and then just my k's, because I want to look at my common bases. So here I just want to look at h first, and then I can look at my k. So I'd have h to the 6th divided by h to the 5th times k to the 2nd divided by k. So using my quotient of powers property, I see here I have common bases, and I see that they're being divided, so I know that I can use my property. So my h's will become, we'll have h raised to the 6 minus 5, and then I can look at my k's. Again, I see I have common bases, my base is the same, it's being divided, so I can use my quotient of powers property to subtract my exponents. So I have 2 minus, wait, what? There is no exponent. Remember, if there is no exponent there, then it is a 1. Because k times itself one time would give you k. So we don't always write it there. It's kind of one of the mathematicians' lazy way to write it. So the 1's there. So I have 2 minus 1. So now I just have to simplify what I have. So I have h equals, and 6 minus 5 gives me 1, times k, and 2 minus 1 is also 1. So I can rewrite this as h times k. Now why don't you go give some examples a try.